Hi guys, today's notes are on 5.6, inverse of a function. This is the last section that we'll be doing in chapter 5 before our test. So the first thing we need to review is what is an input and what is an output. So inputs are x values, outputs are y values, or we call them f of x values. So if I give you a function and I give you the input values, you plug in x's to find y's, right? So this one is f of 0 equals 3 times 0 minus 2, which is 0 minus 2, negative 2. Here we can plug in 4 and negative 8, right? 3 times 4 minus 2, 12 minus 2 is 10, and then negative 8 is negative 24 minus 2, negative 26. Okay, well, if I give you x's, you plug it in to find y's. If you, let me write this in, plug in x to find y. If I give you an output, a y, how can you find x? Well, plug in y and solve for x. So this one requires a little bit more work, right? So y is like right here. So it'll be 0 equals to x minus 5. This is 5 equals to 2x. So x equals 5 over 2. Be really careful. Divide by 2, not by 5. So it'll be 5 halves. And then if I have 3, it'll be 3 equals to x minus 5. Add 5 on both sides. That'll be 8 equals to 2x. So x equals 4. And then the last one, let's do negative 7 here. Solve it, and you should get negative 1. So just a quick review of function notation and how you can find the opposite value. So functions and their inverses. What is an inverse function? An inverse function are functions that undo each other. Okay. Inverse functions interchange or switch the input and output values. So we're going to switch x and y of the original function, and that means a domain, which is your x values, and the range, which is your y values, also switch. Okay. We use f inverse of x to denote the inverse of a function. Okay, so make sure that you know that this is not like a negative 1 exponent. This means f inverse, so the inverse of f, parentheses x. So how can you determine whether each pair of functions, f and g, are inverses? Well, it says here that we need to switch x's and y's, right? So if my x values all become y values and my y values all become x's, y to x and x changes to y, then f of x and g of x are inverse functions because x and y values are exactly switched. Let's take a look here. This, for number 3, the x value becomes the y values. However, when you look at it, the y values do not equal the x values here, right? So it starts to change. So as soon as the numbers are different, the y values and the x values are different, then the answer is no. And you can explain. Okay, because the y values of f of x do not equal the x values of g of x. So here are some functions and their inverses graphed. Okay, and so what do you notice about these functions? hopefully you see that they have the same basic shape. Okay, if it's a line, the inverse must also be a line. If there's like a squiggle of some sort, there's a squiggle. If there's like a half parabola, then there's a half parabola. They are going in different directions though. Oops, so sorry. Apologies. Okay, so they are going in different directions, right? So the graph of an inverse is a reflection of the original function, but it's not just reflected over a y-axis or an x-axis. It's a reflection over the line y equals x. Because it makes sense, right? If we're switching our x and y, then really our line that we're reflecting over is x equals y or y equals x. Where does that line show up? Well, if you guys remember, this is a line. This is the same as 1x plus 0, right? So I'm going to start here, and it's going to be a slope of 1 with the y-intercept of 0. And you are going to go through, from corner to corner, go through each square perfectly here. And you guys see how if you took this point right here at, say, -1, 3, I could reflect it and make it 3, -1 right there. So I'm going to write this in. -1, 3 becomes 3, -1. And it flips perfectly, right? This point stays the same at -3, -3. And so if I switch those, it still crosses at -3, -3. So when you are comparing, given a graph, if I'm asking you if it's a function, an inverse or not, I want you to imagine taking this corner and folding the graph and seeing, like, does this point meet this one, right? So you can find a point that crosses perfectly to see if the x and y values switch. And hopefully this one you can see here. Okay. So like here, this will be 4, 0. So this is 0, 4. This point here at 0, -2 becomes this one at -2, 0. So let's move on to the next one. And your page looks like this. Sorry, I pieced it together. Because you're going to be not given a graph, but we're going to be graphing an inverse function, and then we want to check if it and its inverse are both functions. So the first thing we have to talk about, and this is something that probably came up 2 years ago in Algebra 1, is that what makes a graph a function. Okay, not everything is a function. You have to pass something called the vertical line test to determine if the graph you're given is a function. Okay, so the function, the definition of a function is each x value or input has exactly one output. Okay, it doesn't mean that your y values have to all be different. So notice here, if I put in, say, I don't know, 2 and I get 4, I could also put in -2 and get +4. But what it is saying is that if I plug in, say, x equals 3, for instance, I shouldn't be getting 2 different numbers like I am here. So this is why this is not a function, because I wouldn't know if I'm talking about x equals 3 gives me this y value or this one. It should be very clear that 1x gives me 1y. So we do something called the vertical line test, which is draw a straight line up and down to see if it's a function. Okay, so the vertical line test says that if I draw this line right here, then, and it only crosses my parabola one time, then that is a function. Notice here, this crosses 2 times, so this is not a function. Okay, so the vertical line intersects the graph no more than once, or only once for a function. So let's take a look. Okay, so how can we graph this? Well, this is just a line, right? This is your y-intercept. This is my slope. I know it's linear. Oh, so sorry. Let me see if I can. Okay, sorry about that. Okay, so since it's a line, I'm going to start at the y-intercept of 2. And I'm going to go, a slope is 3 over 1. So I'm going to go up 3 over 1. Please don't just draw a line and then like wiggle over here and hope that your line is straight. Go backwards and go down 3. Backwards 1, down 3, backwards 1. And then you need to label this as f of x. Okay. To find the inverse, you're going to take each of your values and switch it. So this is 1, 5, right? So instead of 1, 5, I'm going to switch my x and y, and I'm going to look for 5, 1. This one is 0, 2. So that becomes 2, 0. This one is -1, -1. When it switches, it goes to the same point. And then this point is -2, -4. So I'm going to -4, -2. Oops, sorry. -2 down here. And it should cross perfectly at one point only. And let's label this as f inverse of x. So let's do a quick check. Are they both functions? So if I draw a straight line up and down at any point, all of the blue lines, like the blue line intersects, take a look at my pencil, only one point right there, right? And if I shift it, it intersects right here. Looking at only the blue line, it crosses at one point only. Now if I look at the red line, which is my original function, then it also only crosses. Okay? So right now to graph it, you can switch the x and y values of the original function. Well, let's make it a little bit more complicated. This is a quadratic. A little trickier. Let's see. What will you want to do for a quadratic? Well, you might want to make a table of values. You could find the vertex. I think I'm going to find the vertex just as a review. You could do x and y values. Okay. So many ways. Let's do x equals -b over 2a. Just as a review, this helps me find the vertex. So -2 over 2 times 1, which is -2 over 2, -1. F of -1, -1 squared plus 2 times -1 plus 2. So that'll be -1 times -1, minus 2 plus 2. -1 plus 2 is 1. So my vertex is -1, 1 vertex. It seemed like a lot of work. -1, 1. From here, I'm going to use my 1, 3, 5 pattern. Hopefully you remember that, because my a value is 1. So my first slope is 1, and then up 3 over 1. And go backwards, and here's my parabola. I'm going to label this f of x. And then take each of your functions and reflect it. Okay, so we know that there's going to be a invisible axis of symmetry here, or line of symmetry. And instead of -1, 1, I'm going to go 1, -1. And then this point is 0, 2, so I'm going to go 2, 0. And this one was, let's write this out just so I make sure I don't make a mistake. 0, 2 becomes 2, 0. Let's see, this one is negative 2, 2. So it becomes 2, negative 2. Okay, so hopefully you're starting to see the pattern that instead of going up and down, this parabola is going to go side to side. So I'm going to go here and here for my last two. Okay. If you weren't sure how I got those points, you can find the x and y values and flip them. And this is my inverse. So is it a function? Well, this graph is a function, but the inverse is not a function, right? Because it's a sideways parabola, it doesn't pass the vertical line test. Crosses vertical line test twice. More than one time. So this is not a function. Okay. Try the last one yourself. Strongly suggest using the multiplier of 3 using your 1, 3, 5 pattern. If you don't remember that, you might need to plug in some more values or use your graphing calculator.